So, let's suppose you had a more realistic situation than the ones we've been dealing with, right? Which is, say you had, let's just do this. So, let's borrow $100 at 5%, just so numbers are easy, per year. And let's ask if you compound yearly, how much will you have in years 1, 2, 3, 4, and 5?
Oh, so this is like. Do people do this
Yes.
when you're like you're saving money? Like, what do you?
Okay, so that's an annuity. So not quite that. So this isn't.
Like,
I'm in a
your money,
repeated.
Like, grows if you don't touch it.
Yeah, so this is not repeated deposits, right? This is grandma gave you $100 and she stuck it in a mutual fund when you were 3. How much is it worth when you're 4, 5, 6, 7, and 8? You guys see that? And then from that pattern, I think we can probably figure out what it's worth when you're 30. Right?
Yeah.
So, let's see. In year 0, so this is, oops, how about we put a label? Year, dollars. So in year 0, how much money do you have?
0.
$100.
Thank you. You have $100, right? In year 1, right, that 365 days after this deposit was made, right, it gets compounded, ka-ching, yes, making money with my money.
Yeah, that's what I mean.
And you get, how much money do you have now?
$105.
Good, you have $105, right? And the way I got $105 was I did simple interest of 5%. Oops, 0.5 but 0.05. You guys with me?
Okay.
Okay. Then, in year 2, this is going to get more complicated to figure out. I have 105, and what happened to the $105?
Interest.
Yeah, I got 105% of that, right? You guys with me? So I'm collected interest on my $105.
So we're the bank in like a opposite of like a compounded interest, like car loan. Like this is good for us, right? We're
Yeah, this is just me setting money in the bank, right? And every year they compound the interest.
But if you owe 105, you're screwed every year. It goes up.
Yeah.
Yeah.
Yeah, you don't want your debts to compound like this. We'll do a compounding debt example here in a second.
Okay.
But it's going to be the exact same thing. So here's your $105 at 105% interest, which is, somebody calculator me?
110.25.
Okay, so why is it more than 110?
Because it's 5% of 105.
Yeah, because it's not 5% again of the 100, right?
5% of it.
It's 5% of the 105. So you got 5% on top of the 5% you had made. That's this extra quarter.
Yikes.
You guys see that? So that extra quarter came from that extra $5 you had that now made you 5% interest. So another way to look at this is to say it's 100 times 1.05, right? That's your 105. And then times another 1 plus 05.
That's when the exponents come in.
And that's where the exponents come from, because if you have 1.05 times 1.05, that's the same as 1.05 squared. So this is 100 times 1.05 squared. So in year 3,
100 times 1.05 cubed.
150.
good. So you're going to have 100 times 1.05 cubed, which is going to give you,
Which
Is it 150 or 50?
Okay, so it's gonna be about $115, right?
$115.76. 76.25. I was
Well,
actually
that's
gonna
happy.
guess that.
I only like that.
I don't like that. So, one way you could look at this is you could look at this as there are, in your $10 here, right? There are two $5 bills that are each gonna earn you a quarter,
Yeah, that's what.
right? So you had a quarter, you get two more quarters from the $5 bills, and then where the heck does the extra penny come from?
The,
So if you think about it this way, right, you had a $100 bill, right? In a year, that got you a $100 bill
and 5.
and a fiver. Right?
Yep,
And at this stage here,
got another quarter.
I had a $5 bill and another $5 bill, right? And each of those made me a quarter.
So your quarters are making you a penny.
Yeah, and the quarter you had, that makes you about a penny. With it? Okay, so here, you have a $100 bill, right? That's gonna get you $105. Right, so if I'm calculating year 4 here, I'm thinking, okay, the $100 bill is gonna give me 105. And then, how many $5 bills is in there?
Got 3 of them.
You got 3 $5 bills, so you're gonna get 3 more quarters.
Jeez.
You guys see that? So you got your 105, you got your $15 that you had, you get to keep that. And then you get 75 cents from those guys. And then you also get
Then,
from your 75 cents,
2 pennies.
close,
3.
probably 3 pennies.
Let's see, you have 3.
And then you also have a penny that's gonna earn you,
A tenth of a penny.
yeah, some little chunk of a penny.
Okay.
0.01 is a
Right? So you're gonna get to keep your 75 cents, and from your 75 cents, you're gonna get 3 more cents, and then you also have a penny, and you're gonna get some little pittance of a penny.
yeah.
Whatever. We'll round that part down to 0. So what do you actually get here?
Nothing.
So what's your total in year 4? I mean, don't figure it out this way, this is
120.
horrible.
1 times 1.
Yeah, it's gonna be 121.
Oh, yeah.
121, what, 20, or 04, I'm guessing, 121.
Let's see.
121.55.
Dang it. Close.
Yeah, so the 5 was, the 0.5 was from these two added together, and the 5 was from these two and that thing.
So, wait, which?
So they're a little bit more than a penny, maybe. I was kind of.
So like an easy way to remember is just every year it adds another exponent?
Yeah, so the better way, right, instead of figuring out this math, is to think to yourself, that's 100, and then it's 1.05, now 4 times. Right, I've compounded 4 times.
So now the quarters became $1, and the pennies became quarters as the years go on.
Yeah.
Alright.
So, as you continue, like, what's the difference between this and simple interest right now?
Principal,
So 4 years?
the
4 years
principal
in,
changes.
if I was doing simple interest on this, what would I expect to have?
You're getting the money instead
They
of
get the
paying.
same amount every year, because its principal doesn't change.
Yeah, exactly. So, if I was doing, this is compounded, right? If I made another line in my table for simple, in the first year I'd have 100, or sorry, in the 0 year I'd have $100, then I'd have $105, then I'd have 110,
10, 15.
then I'd have 115, then I'd have 120. You guys see this?
This is so easy to do on a calculator.
Yeah, this is chill on a calculator. So, what I want you to notice is that this thing here, this is the graph of a line. You guys see that?
Yeah.
So that's gonna look like this.
Yep.
If you graph a function like this guy,
It's gonna be like a, yeah, like a rocket.
it's gonna look like this.
It's like that episode of Futurama when Fry like finds out that he had a
Yeah, that's one of my go-to
put
examples.
like 2 cents in, and then he's like a millionaire and spends it all.
So I forget exactly the numbers. I usually look them up before this lecture, but let's do that as an example quick.
Wait, so what is the, that's your answer?
Oh yeah, what was the answer? The answer was I asked for 1, 2, 3, 4. Oh, and I guess I asked for 5. Where do I get 5 from?
You just do it to the fifth power?
Do it to the 5th power, and so you'll get $127, give or take. Right. So in year 5, right, you're outstripping simple interest by $2.
Mm-hmm.
In year 1,000, you're going to have outstripped simple interest by an awful lot.
Yeah.
You see that? Should we do that for 1,000?
127 plus 6.
Okay, so let's just quick. In year 1,000, right?
You're never gonna do that. What?
Not if you freeze yourself,
Yeah, you got to freeze yourself. That's key to this.
you'll be alright.
Or be a
You'll
Highlander,
be rich.
Or just buy a lot of time.
or buy a lot of time. So if you're compounding, what's your $100 worth in 1,000 years?
100 times 1.05 to the
1,000.
power.
I'm good.
Oh,
Right? And in simple interest land,
Uh-oh.
in simple interest, you get $5 a year, right?
mhm.
Whoa, it gave me.
So you're gonna get 100 plus 5
5,000 extra
times
bucks.
1,000 is gonna give you $5,100, right?
I got the times 10 to the 23rd.
Yeah,
Good.
That's what I call
Cool.
it.
So what was the answer here?
1.54
1.54
times 10
times 10 to the
23rd.
23rd, and that's what's gonna matter,
Yep. Because you're gonna move the decimal over.
because this means you need to kick the decimal that way
23 times.
23 places.
So, you know what that means?
So that's 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh god, 1, 2, 3, 1, 2, 3. So that's 3, 6, 9, 12, 15, 18, 21.
Jesus. Rich.
Eckridge.
Okay, what do you want? Simple interest, compound
What do you
interest?
call that?
I want compounds.
You want compound unless you're paying it.
Yeah.
Yeah.
Right, if you're borrowing money, try to get it simple, and if you're banking money, try to get it compounding.
Yeah.
What?
File for-
How do you? Is that even a number?
Thank
Is
you.
that even a number?
I mean, like we're.
Yeah, so this would be,
Gazillion.
so this is like
Hundreds, thousands,
hundreds, thousands,
millions,
millions,
Billions.
billions,
Trillions.
trillions,
Gazillion.
dunno. Yes, it's this much money.
sextillion.
I'm gonna start one of those for my
Quadrillion.
great.
Fidelity.
Yeah.
Great.
You're there for your kids, your great-grandkids.
Yeah, so this relies a little bit on assuming that in 1,000 years money will A, mean something, and 2, that whoever is holding this account will not have spent it when it got to, there.
Yeah.
We're gonna move along to cryptocurrencies.
Bam, bro.
No.
Okay. Just out of
Questions?
Yeah. Out
Yeah.
of curiosity, just for like a mortgage, is that when you're when
So,
you're paying? Is
Mortgages are annuities. They're yet a different thing. So I need compound interest first, and then we're going to do annuities, but not for 5 minutes.
What are those
I'm
things
just
you
help out me.
buy?
I'm like, I need to know my stuff.
What's that?
It's called it. It's like a big thing. I don't know if it's what it's. It's what is it called?
I don't know what you're talking about.
My English teacher in high school told me about it. You like buy it and it's worth like so much.
A stock or
No,
bond?
no. It's like some weird science thing.
A Bitcoin?
Yes.
That's a cryptocurrency.
the biggest, don't invest in it.
It's the biggest, actually, you should